able to handle that kind of entry. You may have also seen in Google also, sometime whatever the entry you have given as to search, that particular entry is not exactly written correctly, or maybe there is some missing words are there inside the term, inside the whatever the letter, whatever the word, whatever the sentence you have written inside that search box. Then also Google is trying to show you some possible outputs depending upon whatever the input you have given. He never, the Google never tells you that yes, there is no matching found. Very rare cases it shows there that there is no matching found when that particular sentence written by you is completely irrelevant. But if something is relevant or something is meaningful out of whatever you written in the search box, if something is there which is very little bit meaningful and having some meaning, at the time Google tries to show you some relevant response instead of showing nothing is found. So that is the tolerant, how much it is tolerable, that whatever you have given and whatever the indexing system is been designed, so how much it is tolerable, how much it can tolerate, how much it can understand out of the text, out of the sentence that you have written that may not be complete, that may be partially correct. So here we'll discuss some basic fundamental idea about wildcard. Second thing is spelling correction, and third thing is the soundex algorithm. Wildcard means whatever text, whatever word you have written that is not complete. Okay, I want to write, or suppose the user want to write international, but anyhow that particular person is not aware about the exact spelling of that international, the term international. He just know or she just know that inter and this thing does not know the national spelling or the term national, he or she does not know. So in that case, he or she can give some symbol, asterisk symbol, or that means he does not know these things. Only he or she knows this thing. So then also how your indexing system is able to know or identify what are the possible word, what are the possible response that particular user needs to get from your indexing system. And secondly, we will discuss about spelling, about the spelling, how much your indexing system is able to correct the spelling also. If due to some reason that a word is being written or misspelled, then also how your indexing system is able to correct the spelling. And third thing, we'll discuss about the terms which are being pronounced similarly. Then also how your indexing system can correctly identify whatever the word you have written that may be written in wrong way, or that may be spelled in wrong way. We'll discuss later on about this thing. First of all, the wildcards. Look at here, very simple example. Suppose the term is Monday, but that particular person is unknown about the term, the last few term or last few characters of this Monday term. Okay, so in that case, what he or she will do, he will write MON then star or asterisk. Then how your indexing system will identify what are the possible words which are started by MON. Out of that, one of the term or one of the word is correctly needed by that particular person. Yes or no? So in these cases, what we should do, we should maintain a binary tree or B tree, as we used to do in B tree. There, look at here. There is a middle, and left of this may be some smaller, and right of this may be some larger amount of values. So if you are maintaining your words also in this manner, then it may help you to find the possible terms or possible words that the user may need. Okay, so the word, whatever the word is here in the left hand side, must be smaller than this word. Like assume that all the terms started by MON, and the right hand side all the terms greater than say MON. That means after the letter N, M, N, O. So it will be M, O, O. Left hand side, because we are making comparison in which particular position? In a unit place always. If I will say you, out of this 15 and 17, which is larger, you are comparing the unit place only. You are always trying to compare from the unit. So similarly, we are trying to put the smaller values in the left hand side and the greater values in the right hand side. So whatever the next subtrees of this one, MON, may consisting of all the possible words which are being started by MON, initiated by MON. So those are the possible words, and you can provide as a response to the user. Or you may perform some post-processing depending upon how the user will want, or what the exact word being required by the user, so that only that particular word can be shown to the user. Because in this beginning with MON, started with MON, there may be several terms, several words, but the user may need only one word. So you may make some post-processing on that, or you may ask some question to the user that what the type of word you may need, depending on which you are going to provide only that particular word instead of showing the list of words. This is one very fundamental way, very basic way to maintain a binary tree, a bit tree. But the question, when we know the last few term or last few character of the word, but we don't know the beginning portion or the starting portion of that particular term, how to manage that? So as I've told, we are very much comfortable when the end portion, the right hand side portion, is unknown to us. Like here, we can maintain a binary tree or bit tree, and we can give some list of terms or words. But this is the case which is reversed. The previous few portion, previous few words or terms are unknown to us, but we are comfortable with this one. So now what we should try to convert this kind of query to this kind of query, where the right hand side portion is being a star or asterisk. How can I do that? By making the reverse. By making the reverse. Instead of star MON, make it NOM then star. Meaning is same. Make it the reverse of the string. You can do like this. Instead of star or asterisk MON, we are very much comfortable in which way? Where the asterisk is present in the right hand side. That means what can I do? N, O, then M, then asterisk. So now the term is like this, N, O, M, and now you try to maintain this binary tree like this for the term NOM. So we have to, what we have to do? We have to put the smaller or the lesser value to the left hand side and the greater larger value to the right hand side, as we have done earlier for this one. So the comparison must be done in the unit place. So my unit place is having M, who is greater than M, ABCD up to M, then N. So the word must lies in between NOM and NON. So your B tree may have like this NOM and here NON. And as we know, the terms we need which are being started with NOM, because we have reversed. So whatever the possible words are being found over here. After getting that, again make it reverse to show the user. So
Sir, did you repeat, sir, after sir that binary tree, sir, NOM and NON, sir, after that what you have told?
now, is my voice is audible to you? Yes.
Yes, sir, audible, sir,
Yes.
audible, sir.
No, yes, correctly. Okay, then look at here. The terms as you have reversed, now you have NOM and greater than NOM means NON. Is it correct or not?
Yes, sir.
Yes. Then whatever the terms sub or children of this NOM that must contain NOM. Yes or no? That is being started with NOM. Maybe suppose assume that like this A B C NOM ABC. This may your left hand side NOM AAB and right hand side NOM
ABB, that one will be.
ABB like this. Okay, I just assume that this may happen. So
Okay.
all the terms over here are being started with NOM. My requirement is fulfilled. Yes or no?
Yes, sir.
Now make it when you are going to showing to the user, because user need what? User does not know the first word. He or she only know the rest word MON, and all these terms are being, if you are reversing BAA then MON, BBA then MON, all the terms satisfying this condition. If you are make it reverse of this one. So when you are going to show to the user again as an output, make it reverse and show the list of that responses that you have got from your B tree. Is it correct? Huh?
Yes, sir, got it, sir.
Yes, very good. So one exercise for you for try to find the possible list or from your B tree by the help of B tree to find the proper required output response for the word like this: pro, star, asterisk, then set. This is a word where star asterisk at the end, and this is a term where star asterisk on the beginning. You have to make it a forward B tree and you have to make a backward B tree, nothing else. So what you are going to do, you have to make the list of all possible combination by the help of the B tree. You have to make the enumeration or a combination of details of different terms and put in the dictionary. Whenever it is matching, you are going to show the response out for that. So consider another query: C, SC, then asterisk, ATE, and FIL, asterisk, then ER. So you have to perform the forward bit tree for this one, reverse or backward bit tree for this one, forward bit tree for this one, and backward bit tree for this one, and make it again AND operation. They are huge tasks. So this may result the execution of many Boolean AND queries. So you are going to get several terms, may not be a single term. Based on the wildcard, you are getting, suppose for this there are 5 terms, and for this also there are 5 terms. So combination may be 25 terms, because the star is not a single character, maybe more than one character. This asterisk may have more than one character, for which you are going to get 5 character for this, 5 character for this. Okay, so there are several combination. Like here also you are having several combination, and then merge or combine for as it is AND. Then try to find which particular posting list or which particular document consisting of these two words. A huge task. So B-tree handles, we got that B-tree handles stars where it is present at the end. We are trying to put the star or the asterisk at the end so that the B-tree can able to handle. So how can you handle when the star or asterisk is in the middle, as we have done? this one star or asterisk in the middle. We used to put or used to take two types of bit tree and can be handled. So our intention should be that may be the forward bit tree or that may be the backward bit tree, whatever the bit you are considering. Our aim or target should be we just always try to put the wildcard or this star at the end, so that this bit tree can handle this one. So what is the way to put this star or the asterisk at the right hand or the end of this word? For that, we have to go through a new concept that is called Permuterm index. A concept is called Permuterm. It is nothing just new or nothing very difficult thing, very easy thing. You have to perform several permutation combinations of different possible words from the given query and make in the index, put in the dictionary index. Take this example. The word is or the term is hello. The term is hello. Hello. You know that the word is ended over here. Hello, then end. So for every term, for your indexing system, what is your target? Your target is to build the indexing system. Okay, so you know the term, you know where it is being ended, put a symbol, any symbol. Like here we have taken the dollar symbol, which signifies that term is or word is being ended over there. Okay, so the word is not being known by the user because user tries to use some wildcard asterisk symbol. So maybe the entry is ELLO or only H, LLO or HE or LO or HEL or only O or HELL. I don't know what can be the possible entry for by the user. So that is why we should, what should we do? We should maintain a Permuterm index by rotating the character sequentially. We know that dollar is the end of this term or end of this word. Take H to the right of this dollar. That means only ELLO and H at the right. Then again take E to the right, only LLO and HE. Then again, whatever the possible permutation, go through all the possible combination. Right here, L is the left, go to right, then O remains. O remains, L goes over here. So this is the possible combination of Permuterm combination. So what is the benefit of this one? Why should I do this one? Because as you know, we always try to put the asterisk at the right hand side. Our aim should what? Aim should be put the asterisk or the star at the right hand side, so that we can apply the bit tree concept. So if the word is completely given, whole is given, then search for X, the whole word, and dollar. Dollar means end. You can easily find this term, no problem. Okay, so now come to this one. The user knows some preceding word, but the user does not know the ended word or ended terms. Okay, so like here, person knows HEL but LO does not know, so extra dollar you can use by the same your bit tree, because very simple, it's this thing already we know that the term first preceding letter we know and the last character or last few characters we do not know. You can use the bit tree and can retrieve that. Come to here, the user knows some last few character, but he or she does not know the previous preceding characters. So as this is the last few character, we can put dollar over here and make a rotation. Look at here, this one. We know the LLO, the last few character. Look at this question, this one, and look at the example, this one. We know the last few character, LLO. Okay, but we don't know the preceding characters, that is HE. We don't know this HE. So as the all possible permuterm we have maintained in our indexing system, that means it may happen that its preceding all the characters are present after this dollar symbol. That is why you can search for your indexing system this one. Whatever the wildcards are there, those are present after the dollar system, dollar word, dollar term. So we can search or look up your dictionary system for this one. Okay, now come to here. We know the preceding characters, we know the ending characters, but we don't know the intermediate characters. So this is my end of the word. I know the end characters, na? That is why here maybe the dollar. So rotate this to right. X will come after dollar. X comes after dollar. Then again after the X, the asterisk will come. Asterisk will come over here. So now again the same thing happened. That asterisk is at my right hand side. So again I can apply my B tree. So your now task is to solve this one. How can I manage this kind of input where multiple wildcards are there and multiple at multiple position? Think it. Take this example. Suppose the user has given a word where the middle or intermediate characters are unknown. He or she knows about the preceding, like this example for this one. He or she knows the previous preceding character words or the ending characters, but he or she does not know the intermediate characters. So your X is HL and Y is small o. Okay, and you need to make a rotation. X star Y, then shift it. This is your HEL and this is your star, this is your Y. Then make a rotation. H will come over here, then E will come over here, then L will come over here. So this is your required search in your index according to this formula, this rule. So what do you exactly do? You are going to deal with several permutation combination or several number of terms, possible words for a given by a single term, a single word. What will happen due to this? You are going to build a huge indexing system. Your indexing system will be very large. Basically the terms we are using quadruples, means उसको हम बोलते हैं चौतरफा, मतलब बहुत ज्यादा बढ़ जाएगा वो. It will be a very large quadruples lexicon size. The lexicon size will be very much high. We are dealing only with English. It may vary for other languages. So what you are going to do in case of permuterm query processing, you are going to rotate the query depending upon the wildcard, and you are going to put the wildcard at the right hand side. Now you are going to apply some B tree concept as we are doing before, which will make the indexing system or lexicon system very large. For a single word hello, HELLO, you are going to build around 5 to 6 number of words for your index to search whatever the entry given by the user correctly. You are going to get the correct answer, correct response, but the indexing system will have a larger size.